Hi, I'm Aditi, and this is a five-part video on one of my favorite topics, which is VPC. So in this video, we will explore VPC from scratch. We'll see how a default VPC configuration looks like in AWS. We'll deploy our own private VPC and learn all the different things associated with it, configuring routes and security groups and NACLs and everything. We will also try to create a subnet and then make it public and then play around with NACL security groups and see how we can ping machines and how can we actually reach to that machine using through the internet or through the different ports and protocols in picture. We will also try to play around with the communication between two subnets in the same VPC. So a lot of interesting stuff, and let's begin.
Shut up and sit down.
Hey, so let's start deploying our own VPC. In order to do that, just go to the console and go to VPC. When we go here, you can see that currently in this AWS account, there is only one VPC. And this is likely the default VPC, which Amazon creates. So it is default. And you can see that it's set up with certain route table and network ACL. So let's have a look at the IP range associated and the route table here. So you can go and check the routes here that it is allowing the local traffic in this subnet, and also this is the destination through internet gateway. So it also enables connectivity through internet gateway to the VPC. And if you go about the network ACLs, you'll see that there is one ACL. And it has certain rules, but the rule is just like allowing all the traffic. And similarly, all the inbound and outbound traffic. So that is the rule, which is by default. And you would see that there is a subnet association with this. So there are 6 subnets here, and this is the VPC. So if you go to subnets, you can see that they are all deployed in the same VPC. So there's one default VPC, 6 subnets. And when you go to a subnet, you can see that there's a route table, again, network ACL and all that. And these are the ones which were defined by default. So when you have an AWS account, AWS itself by default creates a VPC and creates subnets in all the availability zones, which is a good practice, so that you have instances available, subnets available even if one availability zone goes down. So as a standard practice, it deploys the 6 different subnets, and all of them have the same route table with these 2 routes and a network ACL with inbound and outbound rules, allowing access to all types of traffic on all ports and all protocols. So that is what a default VPC looks like. Now what we'll do is create our own VPC. So let's go to the VPC dashboard. And also see that when you define a VPC, there are a lot of different things in picture, right? There's VPCs that you can define subnets, route tables, internet gateways, and there's something called egress only internet gateways. And we do not have it here, but we'll try to create one. DHCP options as elastic IPs, endpoints, endpoint services, VPC peering connections. This allows the connection between 2 different VPCs. Then you have network ACLs, which is kind of a security setting that you can configure to allow or deny traffic. Network ACLs always operate before the security groups. So security groups also allow you to define an instance level rule of whether a particular traffic is allowed or not. but that is evaluated after network ACLs. And then you have customer gateways, which is a different thing, and virtual private gateways, and site-to-site VPN connections, running instances. So there are a lot of different factors in the same VPC section, and we'll be exploring them shortly. So the first thing that we need to do here is create a VPC. So let's create a VPC here. You can go to create VPC and we can try this IPv4 manual input. So what I'll do is manually input it. So the biggest range is /16. So let's go for that. It allows the maximum number of machines spun up. And how can you find it out? You can find it out by actually checking how many possible IPs can be assigned in this range. So you can go to CIDR and let's do 0, 0, 0 here. So you can see that if it is /28, only 16 are allowed. If it is /24, 256 counts are allowed. And if it's /16, then 65536 number of IPs are usable, starting from 10.0.0.1 till 10.0.255.254. And then there are broadcast IPs and stuff. And even in this range, there would be like 5 around IPs reserved by AWS for its own purposes. So like the routing or other things, like in order for AWS to connect to those things that you're creating, right? It's all ending up on AWS. So AWS needs to connect to whatever you're launching. And for those services, for those AWS services, certain IPs are reserved and used. And AWS also doesn't allow broadcasting, so that IP is also taken up. So let's get back to the VPC creation. So we have defined the CIDR block, and tenancy can be default or dedicated. Default is shared, and dedicated is when you have a dedicated hardware. So dedicated usually costs you a lot, so we will go for default here. And then no tags right now. Now let's create the VPC. So when we click on create VPC, you'll see that this ID is assigned and this VPC is created, Infinite Hags VPC. You'll also see that just like we saw in the default configuration, there is a route table and a network ACL and DHCP option set. So let us look into the route table here, and you will see that here by default, this is the default routes table, and it does not allow any traffic from the internet. So this is all private, local. So it allows local interaction within this VPC. And that is kind of okay. Like now, if you launch 2 EC2 instances in this VPC, they should be able to talk to each other because it is a local route already set up. And there is no subnet association, no edge association, and no route propagation in place. So this is the default route table, and note that there's a difference in this one and the previous one that we saw, which is a default configuration by AWS. And the difference is that the default configuration has an internet gateway, and that is added to the route. But here, there is no internet gateway defined because we have not created it yet. Similarly, if you go to network ACL, inbound and outbound rules, you'll see that all traffic is allowed inbound and all traffic is allowed outbound. So in order to configure it, you can configure it like based on your security requirements, but in order to have a communication, this is pretty much what is needed as default. If you go to security groups, you'll see that there is one security group which is created by default, which is this. And again, it allows all traffic. And this is by default available. So it'll allow all incoming traffic. This is the inbound rules. And then the outbound rules are also that it allows all the traffic. And you can edit outbound rules. All right. So just like NACL, there are inbound and outbound rules defined here. Okay, so now let's do one thing in this VPC, which is this one. Let's create a subnet. Okay, and we'll try to create one public subnet and one private subnet. But currently, if I ask you to reach any resource in this VPC, do you think we can ping that resource? Because there's no internet gateway here. So let's try that out. Let's see if I deploy an EC2 instance in this VPC and assign a public IP to that EC2 instance, can I reach it from the internet? So let us go to EC2 instances page and create an instance. So you can pick up anything. It doesn't really matter right now. See that you have to pick Infinite Hacks VPC here, and there's no subnet. A subnet is required when launching into a VPC, right? So you cannot actually launch an instance without a subnet, right? So we cannot just deploy an EC2 into VPC and check whether it's reachable or not. We need to create a subnet.